Welcome everybody to our next webinar which features Professor Anne Doucette. We're very happy to have her talk about IRT today. Dr. Anne Doucette is a professor at the George Washington University in Washington, D.C., and she's the director of the Evaluators Institute and the Mitch Smith Center for Evaluation Effectiveness, which are both internationally renowned in the field of evaluation and professional training. And she has a vast experience in the management and evaluation of intervention programs, as well as the development of outcome measurement systems at the individual and system level of care. She has great experience in the development of research methodology, data collection, strategies, and measurement techniques, including both quantitative and qualitative approaches, and is particularly focused on using item response theory, on which you will talk today. And we're very happy to have her in this series, and we'll hope that everybody will learn a lot about IRT today. Welcome, Anne. I will first start by explaining for the new people how things work in the webinar. So I'll just introduce that very briefly. If you have any questions, either practical ones or questions for Dr. Doucette, please type them in the question window so that we can see if you have a question. And what you can also do is raise your hand if you have a question. If you look in the attendee window, you have the possibility to raise your hand, and we can see that, and we can open your microphone if you have one. If you don't have a microphone, or for instance you're watching on your iPad, and then you won't be able to use that feature, you can type in the question window, and we'll ask it for you. So, well, Anne, if you want to start, you have the floor.
Okay, thank you, Kim, and I'd like to just say good morning or afternoon, depending on where you're watching and listening. We're going to focus on IRT and measurement. Measurement for me is the foundation of psychotherapy research, in that we use measures to make a determination with regard to how well people are doing in treatment, the effectiveness of various treatment models, comparing one to the other, and so forth. So what I'd like to do is to focus on some of the learning objectives. And what we're going to do is focus on measurement and the need for precision, a basic understanding of the differences between classical test theory, and this is the measurement approach for which most of the instruments that we're currently using have been developed on, and contrasting that with item response theory. I will say from the very beginning that I have a personal bias towards the advantages of IRT, but nonetheless one can arrive at similar conclusions using classical test theory. However, it's a lot more labor intensive. We're going to discuss the advantages IRT offers over classical test theory. We're also going to describe some of the basic characteristics and assumptions of IRT models. There are many IRT models. We're going to be concentrating most specifically on the Roche model, which is often described as a one-parameter model. And we'll talk about the difference and when one might want to use multi-parameter models and the advantages of doing so. We're going to talk about the implications of dimensionality, which is a critically important measurement concept, because when we do a measure, we come up with a summative score, and we're assuming that that score represents a unidimensional construct. And if in fact multidimensionality goes ignored, then that one score really is talking about more than we think it is. We're going to talk about the pivotal role of measurement as the foundation of psychotherapy research. I wanted to share with all of you a definition of measurement, and this is from Michelle in 2001, and it's really a scientific method. I'm going to read it, a way of finding out more or less reliably what level an attribute is possessed by an object or objects under investigation. In our case, it would be the level of depression, the level of anxiety, the level of psychopathology, and so forth. And we're interested in the magnitude of a level of the attribute via its numerical relationship to another level of the same attribute. So we want to differentiate how well people are doing in terms of the degree of impairment that they're experiencing. And we want to see what changes as a result of the introduction of psychotherapy. Some basic assumptions of measurement, and this is independent of whether we're talking about classical test theory or we're talking about item response theory. And we're talking about reliability, and reliability is the consistency across observed scores for a particular attribute. We're not assuming that an individual would have the same score each and every time that we ask him or her to complete the measure. What we're saying is that they would obtain the same scale score placement on different occasions. One of the easiest example would be that if we were doing a test of mathematical competency for grade school children, we wouldn't expect that on a measure a child who's failing mathematics would all of a sudden on the same measure be excelling in mathematics, and on the third time be failing again, and vice versa. We would expect that the person would improve in terms of mathematical competency, but they would stay in the same measurement placement. Validity, and that's the accuracy of the measurement in terms of the expected scores, and that's for a given population and a given purpose. And validity, unlike reliability in measurement, is a matter of judgment. There are some coefficients, such as construct validity, where we're doing the factor structure and so forth, but factor analysis and so forth with regard to validity really yield evidence on which we make a judgment. Dimensionality is often overlooked in terms of measurement. We rely heavily on reliability and validity, but seldom do we focus on dimensionality. And that means that the scores, the items in our measure, are interpreted as assessing a single trait: depression, anxiety, psychopathology, and so forth. Multidimensionality really makes it impossible to distinguish the attribute that we're assessing via that measure. So dimensionality is critically important in terms of measurement. What we want to talk about in terms of measurement function is when we ask people to complete a measure, we want to make a determination in terms of, especially at baseline, how much of an attribute they possess. So how depressed are they? How anxious are they? What kind of emotional and psychological distress are they experiencing? And typically in psychotherapy research, what we're looking at is some sort of improvement or change in that level over the course of time that we can attribute to the psychotherapy models that we're using. So essentially we want to put people on a ruler. And that's what measurement is, putting individuals on a ruler. You can see from this illustration that we have a person located at the mild end. We may have people located at the moderate end, and we have people located at the severe end of whatever the construct is measuring: depression, anxiety, emotional, psychological distress, and so forth. And we want to array those individuals across that ruler as precisely as possible. This is an example. I'll go back to mathematics because it's relatively simple to understand. So we have a list of respondents on the left-hand side. At the bottom, we have students with very poor mathematical skills. At the top, we have students with exceptional mathematical skills. And if we had all of these students ranging from poor to exceptional skills in a classroom, we would really want to have items that were arrayed in terms of measuring basic mathematical skills: addition, subtraction, multiplication, as well as items that were really indicative and characteristic of exceptional mathematical skills: calculus and trigonometry. If in fact the student gets all of the basic math skills questions correct, but we don't ask algebra, geometry, calculus, and trigonometry, we can't ascertain whether the individual has exceptional mathematical skills. all we can say from that measure is that the person has basic skills. If in fact the student gets all of the calculus and trigonometry questions right, we feel more confident in assuming that if we had asked the basic skills questions that they would also get those right, because those skills are fundamental in terms of the calculations that would be performed with calculus and trigonometry. If we had a measure that only asked the tough questions and a student conversely got them all wrong, we would know that they didn't have exceptional mathematics skills, but we wouldn't know where to place them in terms of whether their skills were poor or moderate. So it's critically important when we have measures that we have what we call bandwidth in terms of arraying people on that measure that we saw in the previous slide. So while this is a pet peeve of mine in terms of measurement, we really applaud the use of sophisticated analytic approaches and so forth, but we rarely question the soundness of the measures that we use to support the decisions that we make about the effectiveness of psychotherapy intervention. Typically, we use measures primarily because they're the most often used measures in the literature. Another study that was of a similar nature used that measure, so we feel confident that, in fact, that measure is sound. And as we go through these slides, we'll learn that perhaps it is not. So some measurement approaches: classical test theory, which is often called true score theory, is the most often used. And measurement has a lot of jargon. So classical test theory can be called true score theory. IRT is really a latent trait model, and it's referred to as strong true score theory. It sounds like a pejorative statement, and I'm sure that the people who characterized IRT models as strong true score theory would like to propose that it is in fact stronger, but that's a determination that you can make at the end of this webinar. Latent trait models are divided into Roche models, which are referred to as one-parameter models, and item response theory models, which include one-parameter and multi-parameter models. And we'll talk about the distinction between that. Classical test theory is the most often and frequently used measurement approach, primarily because it's taught more frequently in measurement courses as part of statistical courses as well. Latent trait models are increasingly more used in educational testing and more recently in physical health care. They're growing in acceptance of behavioral health care, and they're part of the United States National Institute of Health Roadmap for Medical Research Initiative. They have, over the past several years, developed what we call the Patient-Reported Outcome Measurement Information System, which is the PROMIS system, which has a battery of measures, an item bank that cuts across 10 different dimensions: anxiety, depression, sleep disorder, physical pain, and so forth. In classical test theory, as we said, it's called true score theory. And we call it true score theory because every score, this is important, is made up of the true score, what an individual would have received if, in fact, all of the testing conditions had been ideal. If the person wasn't fatigued, if the person had a perfect understanding of what we were asking with the item and so forth. And then there's random error because there's seldom a perfect situation. We're assuming that the error is normally distributed and that it's uncorrelated with the true score. In other words, males, females, people who are black, white, pink, and blue would be just as likely to have error associated with their responses. The item characteristics are measure and sample dependent. This is really critical to remember. Each and every time a measure is given, the reliability should in fact be recalculated because the reliability is a characteristic of the scores and it is attributed to the sample, not the measure. All items contribute equally to the overall scale score, unless we use some sort of separate weighting scoring protocol. So for example, in a measure that has 10 items, you would simply add up the responses. If it was on a 5-point Likert scale ranging from 1 to 5, and you had 10 items, the scale score would go from 10 to 50. And so forth. We can take a mean score, but essentially we're assuming that if we're adding across all of the items independent of whether we're using a total scale score or the mean across those total items, we're assuming that all of the items really contribute equally to that scale score. And we'll check out that assumption as we move on in the webinar. Response options, we're assuming Likert scales, which is the most typically used in measurement. We're assuming that they're analyzed as equal interval scales. And we make the assumption, whether it's articulated or not, that a 2 is half as much as a 4 and so forth. And we're going to ask about that and check out that assumption as well. In item response theory models, we're talking about modern latent trait theory or strong two-score theory. It's an alternative scaling methodology, and we're talking about a hierarchical structure with unidimensionality and additivity of the items and measure scores. In measurement, if we're adding across the items, we're assuming that we have additivity and we're reaching one score that really represents a unidimensional structure. Estimates are provided for each individual item and each response scale. So this is very different. We have in IRT analysis the ability to look at estimates that will allow us to determine the precision of the item, the item's contribution to the overall scale score, as well as the error that might be associated with each response scale option. So for example, if in fact you're leaning towards 5-point Likert scales or 7-point Likert scales in the hopes of getting more variability in terms of the responses, you might realize that sometimes people are not using response scale options. When we provide a response scale option, we're assuming that the person has a mental schema in terms of making a determination of the difference between strongly agree and simply agreeing, and that mental schema is employed consistently across the items in our measure. And that may or may not be the case. In IRT, we're making an assumption that the items have the potential to differentially contribute to the overall measure score. So we're making the assumption that answering more difficult items should yield a higher score. So if we go back to that mathematical example that I gave a few slides back, a person who is answering the calculus and the trigonometry and the advanced algebra should get a higher score than the person answering an equally correct number of items, but only those items that pertain to basic mathematical scores. So some of the assumptions of IRT models, like classical test models, is unidimensionality. We're assuming that the items measure the same underlying construct and that there's a dominant first factor. The thing to remember in all of measurement, there is never an ideal state where everything is perfect. So we're talking about unidimensionality in terms of unidimensional enough. Is there the presence of multidimensionality, and is it to such an extent that it erodes our measurement model? We're talking about local independence, and again, I apologize for IRT. We have a lot of jargon, and local independence simply means that the item is conditionally independent of the responses to other items, that the latent variable explains how items relate, that a person with high depression would have a specific response profile across items, especially if those items were similar in nature. We'll also have what we call monotonicity, and that's consistent increase. We call that theta. And when we're talking about proficiency in psychotherapy, we would talk about proficiency in terms of the extent of depression, the extent of anxiety, the extent of emotional and psychological distress. And the expectation is that a person would use consistent response options for items having like difficulty, items having the same amount of depression, anxiety, or distress. And I would invite any of you, if you have any questions along the way, to please feel free to either raise your hand using the webinar software or to type in a question. And item response theory models, it's a statistical model, it's a latent trait model, and we want to represent people in terms of where they are on the ruler. We want to locate individuals in terms of whether they have mild, moderate, or serious distress, anxiety, depression, and so forth. We also want to be able to ascertain the level of impairment along that measured construct, the strength of an individual's attitude if we're asking about attitudes towards specific psychotherapy models, if we're talking about competency in academic areas such as mathematical competency, the level of their mathematical expertise, and so forth. So the item parameters, when we're talking about people, we want to locate them on the ruler. When we're talking about items, we want to know which items are easy to respond to, which items are difficult to respond to. In mathematics and academic, it's easier to understand that. We're talking about which items are difficult. They would be the calculus and trigonometry and so forth. If we were talking about depression, we would talk about easy to endorse items such as feeling blue from time to time, as opposed to a more difficult item to endorse, wanting to hurt oneself, wanting to end one's life, having suicidal plans, and so forth. And that would be difficult for all but those individuals experiencing severe psychopathology, serious emotional and psychological distress. In IRT models, we have a number of models. The Roche and the one parameter model assumes that when we're talking about items and people and the difficulty of the item, they're on the same axis. So we have people, the expectation that a person with mild depression, we have an assumption that those individuals would answer feeling blue once in a while, but would have a very low probability of answering feeling suicidal. The two-parameter model really makes a distinction between where the person is on that ruler, mild, moderate, and severe, and which items are indicative or characteristic of mild depression, moderate depression, and severe depression. We have three-parameter models, which guessing. So we can actually identify the amount of guessing that an individual does. Guessing is important in multiple choice and academic and standardized achievement tests, because the instructions that most people receive in completing those measures are you answer the questions that you know the answer to, and then you simply go back and guess at the answers that you think are most plausible. Guessing is really not a parameter that has a lot of interest in terms of psychotherapy, although individuals like Niels Waller and Steve Reese are really talking about the use of three-parameter models for personality testing. That would be a way of indicating and identifying an individual that might be using a social desirable response profile in terms of wanting to present a certain personality style. And we also have the introduction of the fourth parameter, which talks about the contribution of carelessness. This would be a person who is completing a measure and is careless. A good example of this would be an individual who has high levels of mathematical competency but gets a low-level math question in because he or she simply puts the decimal point in the wrong spot. And we can distinguish between guessing and the four-parameter model. In IRT, we have, it's the same as in any measure, certainly the same in classical test theory. We have dichotomous, yes, no. We have polytomous, partial credit. These are response options that are ordinally scaled. So in multiple choice questions where we have a correct answer, but some of the incorrect answers are more correct than others. And then we have the rating scale model, which is probably most characteristic of the instrumentation that we use in psychotherapy research. In the Roche model, in the assumptions, we're talking about one of the first questions that I ask when I'm talking about IRT are all items really equally discriminating? So if we ask a question about suicidality, is that equally discriminating in terms of the level of psychopathology as feeling blue every once in a while? We have the items, as we said, measure a unidimensional construct. It's interpretable in terms of ordering the items from mild to severe. So in IRT, we have an ordering of the items in terms of the level of that unidimensional construct. So the suicidality item would be really ordered at the high end, the severe end, while the feeling blue every once in a while item would be indicative and characteristic of mild or moderate psychopathology. Additivity. We want to be able to add across those items and to have some confidence and assurance that the number really represents this unidimensional construct that we're calling depression, anxiety, psychopathology, emotional distress, and so forth. Monotonicity, the increasing relationship between theta, the difficulty of the item, and the item response. So we may have a suicidal item which is measuring severe psychopathology, but we have a response option that gives our respondent an opportunity to say, this is not characteristic of me, or this is very characteristic of me. I disagree, strongly disagree that this represents me. I strongly agree that it does. And it's the response options that allow us to differentiate the item in terms of severity. Individuals with more of the attribute are expected to answer accordingly. And we have local independence, so we're assuming that the responses to the items are independent of responses to other items and so forth. That the latent variable really explains how the items are related to one another, and it's not the result of demographic characteristics or item bias. In the Roche one-parameter model, we set the location as the curve moves forward, and we'll see a graphic. We can determine whether the item is indicative or characteristic of mild, moderate, and severe. In classical test theory, the statistic that is most closely related to item difficulty is P, the proportion correct. So people who get hard items correct have more general distress, depression, mathematical competency. People who get fewer items correct have less of it. The C parameter, which is guessing, if we're using just the Roche or the one-parameter model, is simply set to 0. And the IRT model with only the B parameter is called the Roche model or the one-parameter model, and this is what we'll be focusing on for most of this particular webinar. So we have an item curve, and we see the response probability goes up. As the response probability goes up, the curve moves across theta, which is the difficulty. People on the right have a higher degree of the construct that we're measuring. People on the left have a lower degree. So we simply drop the line down at, and this is a 50-50 probability. So the probability, the difficulty of that item is 0.025. If we have another item which has a steeper slope, and so we're saying that this item is a little bit more discriminating, and we're talking about this item, if we move from the 50-50 mark on the probability, this would be the person has a 50-50 chance of saying yes or no to this item. The item difficulty of this would be minus 0.03. Theta is, in the Roche model, is in logits. We use logits because we have equal intervals. So we're taking raw scores and we're creating measure scores which are logits, which allow us to intervalize the Likert rating scale that we're using. We have slight differences, although most people will talk about the Roche as being a one-parameter model. But there are slight differences which I just want to make you aware of. In the Roche model, we have a local fit of the data, one parameter at a time. In the one-parameter model, we have a global fit of the model to the data. So in Roche, it's always the data are fit to the model. And one parameter, two parameter, three parameter models, the model is fit to the data, and there's a slight distinction with that. In Roche, we parameterize each member of the respondent sample individually. In a Roche analysis, we will be able to identify the individual respondents that are aberrant, and we will actually estimate our measurement model with and excluding the aberrant respondents. And the one-parameter model, which would be the same in two and multi-dimensional models, we summarize the respondent sample as a normal distribution. So we're treating the sample as one. The item characteristic curves are parallel with the slope. We use a natural logistic ogive, and in one-parameter models, we are actually using a cumulative normal ogive, and in order to make the one parameter equivalent with the Roche model, it's parallel with a slope of 1.7. Items violating the model assumptions, in other words, they're not supporting the model assumption, are deleted from the model. And in the one parameter, and the same is true in multi-parameter models, we're actually fitting the model to the data. So if in fact you're developing a measure, the Roche model is superior, because in developing a model, you want to identify which items really fit that measurement model. And you want to identify the items that do not, so that you can revise those items or delete them from the model. In one, two, and three parameter models, you're actually talking about the fit of the model to the data, so that if in fact you're using measures in your psychotherapy research that have already been developed, then you can actually fit the model to the data and explain the variance from the measurement model. In developing measures, you don't want to explain the variance. You want to make the measurement model as precise as possible. We're just going to go through the two and three parameter models quickly. In the two-parameter model, the steepness of the curve is indicative and characteristic of the difficulty of the item. And the closest relative in classical test theory is the item total correlation, how well the item correlates with all of the other items in that particular measure. The steeper the curve, the more discriminating the item is. What I like about IRT is even people who don't really have a sophisticated understanding of the mathematical underpinnings, the graphics can actually convey a story that is readily easy to understand. As the A parameter, the item discrimination parameter, decreases, the curve gets flatter until there's just no change. Items with very low discrimination provide very useful information because they don't distinguish. Everybody's either agreeing or disagreeing. You have ceiling and floor effects on these particular items. And if everyone is endorsing the same level, then you have no ability to distinguish between those individuals. So we'll show an item. The blue item on your screen has a more sloping effect. The red item is much more discriminating. The blue item is satisfied with life. The red item is using alcohol and drugs to get going in the morning. And essentially, if we look at the blue item, this is going to give you a more relaxed slope. And the logit difference is 6.38, meaning that we can discriminate across this item individuals who have mild, moderate, and high satisfaction with life. So we can make much more gradations in terms of discriminating the level of life satisfaction with this particular item. And these items come from the LSQ, which is Mike Lambert's scale that was adapted for a large insurance company, and the item is on a 5-point scale ranging from 0 to 4. The alcohol and drug item is on the same level, and we see that we have a very steep slope, and we actually have a logit difference of 2.0. So what we're really talking about in this item is really functioning as a dichotomous item, and if you can look at the wording of that item, I use alcohol and drugs to get going in the morning. You really don't need a 5-point scale. You either do or you don't. So essentially what this item is saying, even people who are using the 0 or 1 to indicate that this is not characteristic of me, there's no distinction between the 0 and the 1 or the 3 and the 4. And this is the formula for obtaining the item discrimination. When we talk about the 3 and the 4 parameter model, we're talking about the upper and lower asymptote. The upper asymptote is guessability. These are people who are guessing. This is really characteristic of multiple choice items where we're actually instructing people, if you don't know the right answer, guess. If you have 4 choices, you have a 25% chance of getting it correct. And the lower is guessability, and it looks like this. So we have the slope of the item, the inception point, and if in fact the slope is in the lower asymptote, we can estimate guessability, and the upper asymptote we can actually estimate carelessness. As I said, Niels Waller is doing a lot of work in personality in terms of people trying to fake certain personality styles. Item difficulty, we're talking about the proportion of individuals answering the item correctly. As I said, in classical test theory, it would be the p-value. In polytomist, it would be the mean score expressed as a simple proportion. Those people responding in terms of strongly agree, disagree, and so forth. Let me say that if in fact you have a 5-point scale and your scale goes strongly agree, neither agree nor disagree, and strongly disagree, if in fact you are categorizing that midpoint as neither agree or disagree, that is essentially missing data, because the person who is endorsing that says that they can't make up their mind, they're not agreeing, and they're not disagreeing. Technically, you should delete that, include it as missing data. And seldom do we do that. In fact, a 3, which is neither agree nor disagree, is treated as though it is more than a 1 or a 2. So the advantages of IRT, because we're modeling the data, we're essentially saying that a person with low levels of depression would have certain probabilities of answering certain items in a certain way. It is sample invariant, because what we're saying is that all individuals with mild forms of depression would have a very low probability of answering positively items that are indicative of suicidality. So we're modeling and estimating the item properties at each item level. We're estimating the item contribution to the overall test, so we have more precision. And we're looking at the precision of the response options. So we can tell, using an IRT model, whether we get more precision by giving people more options to choose from, or whether we get more precision from lessening those options. We can calibrate across measures. So if the LSQ and the CESD for depression and the Beck Depression Scale were recalibrated using IRT, we could equate across those scales, and we would know that a scale on the CESD would be equivalent to X score on the Beck Depression Scale. It's also the foundation of computer adaptive tests. In classical test theory, we have some limitations. There's no modeling of data at the item level, so we don't know the contribution of each individual item. The measurement error is assumed to be common to all items, so hard items and easy items would have the same level of error. We'll check that out. The measurement reliability is sample dependent, because it is a characteristic of the scores of the measure. It is not, it's not sample invariant. Additional limitations, we have the ability to equate across different measures, but it is very much labor intensive and so forth. We have challenges in developing brief targeted measures because the rule of thumb in classical test theory is that if you want to measure with high reliability, have a large sample and a large number of items asking similar questions. In IRT, I wish we could say we have fewer limitations, but we have different limitations. Separate software is needed to conduct the analysis. Expertise is needed in terms of selecting the models and the parameter estimates. Larger samples are needed because we're not only modeling the item contribution to the measure, we're modeling the response option contribution to the measure. So larger samples are needed. If you go with multiple parameter models, the sample sizes increasingly get larger. Any questions? And before we go in, and what I want to do on to the Roche measurement model is its focus on the fit in terms of the measurement model. What I'm interested in, do the measures that we use for psychotherapy, are they really are they depression, anxiety, psychopathology, and so forth, been developed in the literature? I will use additional parameters because I want to explain the variance in the measurement model. But if, in fact, I'm making and developing a measure, I want to use the Roche measurement model. The Roche measurement model also enables us to get estimates for guessability and item difficulty as well. So the Roche measurement model assumes that items are distinguishable in terms of item difficulty. In other words, a mild depression item is distinguishable from a suicidality item, which is characteristic of severe depression. The Roche model provides sample invariant, sample independent item calibrations because we're talking about logit. We're talking about the log odds probability that a person with X degree of depression will have in terms of answering, I'm blue once in a while, I am thinking about ending my life. The Roche model also has fit statistics that allow us to look at the respondent's expected scores in comparison to his or her actual response. So a person who has high level of depression and is indeed suicidal would have a probability of saying that I feel blue once in a while. So the Roche measurement model uses this Roche ruler. A person with no depression might endorse items about feeling sad once in a while. A person with very severe depression would endorse favorably items about suicidality. We would have moderate items going across. So a good depression scale, especially if we had a sample of individuals from experiencing mild to severe depression, should have items that cut across this ruler. And the measured construct can be interpreted in terms of low need for psychotherapy intervention to high need for psychotherapy intervention. I want to make this a little bit more sophisticated, and essentially we have a construct that goes from mild to severe, which is often the case in psychotherapy research. And we have items that are calibrated. We have items that are calibrated from the easiest item to the hardest item. And these are our theta calibrations. So we have our first person. Our first person somehow gets into our psychotherapy study, and this person says that none of these items are like him or her. So we don't have any way of characterizing this person with our measure. This person can only deteriorate. If this person stays the same, we can't say that psychotherapy intervention is improving his or her life because we don't have any items that really characterize this individual. If we have an individual, person 2, who's in our study, this person's in the middle. This person has items on these measures that indicate improvement, lower scores, or deterioration, higher scores. So this is a good measure for this person. This person, using this measure, can tell us whether they're improving as a result of intervention or deteriorating. We might have an individual who says yes to absolutely everything. This is a depression item that goes from mild depression to severe depression, but does not include any items on suicidality. And yet this person is suicidal. But we haven't asked that, so we can't characterize that person at that level of severity in terms of depression. This person can only tell us that they're experiencing improvement. If this person was on the precipice of suicidality, we would not be able to detect that deterioration because our measure simply was insensitive. We call this bandwidth. This is probably the most critical problem with psychotherapy research. In a study that I actually conducted with the large insurance company, the items did not have a wide enough bandwidth. There were individuals who were in the study that were improving, but they improved to the point where they couldn't, using that particular measure, couldn't indicate additional improvement. They run the risk of the insurance company saying, there's no movement, there's no further improvement, let's stop the treatment. And so treatment is not authorized. And yet, the person may experience continued benefit from psychotherapy, but the measure is insensitive. And conversely, the same is true in terms of people at higher levels as well. Some examples in turn, I'm going to show you two data sources. The first one is from Project Match. This is the University of Rhode Island. This is the stage of change, the Eureka. It was funded by the National Institute of Alcohol Abuse and Addiction. It's a 6-year study. The sample size is approximately 700 volunteers with alcohol abuse and dependence. I also want to show you as an example the life status questionnaire. This was an adaptation of the OQ measure that was used in a large behavioral health care setting, and we have a sample size of 258,000 individuals. Neither of these samples give us any kind of power problems and so forth, and I've provided just a few of the details in terms of the demographic backgrounds for these two studies. The first thing we have is when we run a Roche model, and these measures are from the Roche, these are outputs from the Roche model, and what we're looking at, model fit. And what we see is we have in-fit and out-fit. And the in-fit and out-fit are reviewed in terms of noise. The rule of thumb is that you're looking for a mean square of 1.4 or higher. And that would be the same for in-fit and out-fit. So we have 3 items here that really don't fit the measurement model. This is a 30-item scale. 27 items are really focused on psychopathology in terms of emotional and psychological distress, being happy, hopelessness, feeling blue, nervous, difficulty concentrating. The 3 items that don't fit are all related to alcohol and drugs. Trouble because of alcohol, using alcohol and drugs to get going in the morning, people criticizing drinking. So keep that in mind. There's one other item that has misfit, and that's concerns about family troubles. So 4 items really have some misfit. So you're thinking about questions like, do these items really fit? Is this a multidimensional item? Are these items interpreted differently, and so forth? We'll go to the Eureka. And we have a number of items that are indicative of model misfit, presenting noise to the measurement model. So this is the first thing we check. And in this particular measure, we have, let's see, 9 items out of this measure are indicative of model misfits. So this is a troubling measure that is often used in addictive research. So here's another graphic along our ruler. We have on the top of the ruler, we have an array or sample size, individuals that go from mild to moderate. Below the horizontal line, we have our items. And you can see in this graphical illustration, we have a certain portion of our sample where there are no items to characterize these individuals. So we have to ask ourselves, are the items sufficiently co-located with the respondents in our sample? Do the measures we use in psychotherapy research really characterize each and every person in our sample? Now, obviously, there are going to be some outliers in every sample, but if in fact we have high proportions of individuals in our sample that are not characterized by our measure, they have no way of telling us whether they're improving or deteriorating as a result of psychotherapy intervention, which is a huge problem. This is another output that's characteristic of all IRT software. This is from the Roche WinSteps program. And this, on the left-hand side of this vertical axis, are the individuals. This is from the Global Distress, the insurance policy study, 258,000 people. And on the right are the array of items. You see at the top are the 3 alcohol items and suicide. They are the most difficult items. On the lower bottom of that distribution of items, this is the right-hand side of the axis, are feeling stressed, concerned about family problems, feeling irritated, and so forth. They are items indicative of less emotional distress. But you see that we have individuals in this insurance study that are below those items, meaning that those individuals have no items that characterize where they are. This is baseline. Those individuals can't talk about improving, yet they may feel that they are benefiting and no doubt are from psychotherapy intervention. So the persons are fairly well matched and so forth, but we do have a proportion of individuals with no items, and at the top and the bottom. Also, items that are clustered together, very important, they're redundant. So feeling lonely, nervous, feeling blue, you may say that feeling blue is distinctly different from feeling lonely, but lonely and blue may be very similar. Items that are clustered together give us an opportunity to shorten that measure. Briefer measures can be more precise. And why? Because we're talking about people that are experiencing some sort of distress, and we're assuming that they're using the same mental schema. So that if we give them 30 items or 45 items or 100 items and so forth, that there's more burden in terms of the respondent than would be in answering a measure that had 10 or 15 items. So let's look at, we'll tip this another way. Here's the distribution of individuals, and we see that we have a fairly normal distribution. It's a little bit skewed in terms of people having less distress, and this is understandable. This is an insurance study. People receive benefits by virtue of their employment, so they're not distressed enough not to be employed, and so forth. And here's the distribution of items on the global distress scale. So we have an item gap. 41.3% of the individuals really don't have a sufficient number of items that indicate that they are experiencing some level of psychological or emotional distress. After all, they got into treatment. They sought treatment out. We're assuming that they have some sort of distress. But there are no items to indicate that. There are no items to indicate that that milder level of distress is actually improving. There's another item gap as we go towards increased difficulty, increased distress as well. Let's take a look. The items are clustered here. So there's an opportunity to reduce the number of items there. And if I were looking at retooling this item, and my response to the insurance company was that we need to work harder to get more items that really allow people to say that they're experiencing mild distress and that they're improving, that mild distress is getting milder and milder. And the same is true that we need items that indicate more serious distress. This item did not include any items that reference suicidality, and as a result, the insurance company dropped this item and developed their own measure. This is the Eureka stages of change in the cocaine study and so forth, and you can see that people are really higher up than the items. There's a mismatch between the items, and the gap is much different on the Eureka. I'm showing two measures. I could show you a number of other measures, and they're very, very similar. So there are no items to differentiate these individuals in terms of the degree of readiness to change. This is a big problem. And there's item clustering, which means that we're asking a lot of redundant things in terms of this measure. We're seeing that 56.3% of the sample, there are no items to accurately locate their readiness to change. So how useful is this particular item? Again, we see another way of looking at this in terms of the distribution of items, and above the horizontal axis are the individuals. The green bars represent the items, and we see a big proportion of individuals with few or no items to really represent them in terms of stages of change. Big problem. When we look at item characteristic curves, as we said earlier, the steepness of the curve really allows us to judge how well the items really discriminate. Items with sloping curves discriminate across a broader part of the sample, while items that have steeper slopes really discriminate in terms of a very small segment of the sample. The less discriminating items, as you can see from this graphic, are about alcohol, and so forth, and people criticizing drinking and so forth. These items are really operating in this particular scale, this is the global distress scale, as dichotomous items rather than on that 5-point Likert scale. We're going to look at dimensionality, and we're going to, when we talk about dimensionality, we're not asking the question.
Anne?
Yes?
Can I interrupt you for one
Absolutely.
second? We have a question here. It's from the group in Trier, and they're asking, how could we improve measures to better measure in a less severe or more severe range?
What I typically do is that I conduct item writing workshops, and I actually go to people who are experiencing or have experienced psychotherapy intervention, and ask them, in fact, when you were improving, what kinds of things were you still experiencing? All of the measures in psychotherapy, I've done IRT analyses on the CESD, the Beck Depression Scale, the Beck Hopelessness Scale, the LSQ, the CESD, and so forth. All of these measures really have very few items at the mild end, and that's a big gap, because I really do believe that people benefit from psychotherapy intervention even though their levels of distress are not at the moderate and severe end. And if we want to be able to justify that to the people who are paying for the treatment, we need to show levels of improvement. So I would actually go to people who are experiencing treatment and ask them to talk about, this would be a qualitative research study, talk about their experiences.
Okay. Well, thanks. That was the question.
And on the higher end, all we have to do, especially if we're talking about distress, is to include items about self-harm or suicidality. Those items are often not included in the measure, primarily because people don't want to be responsible, in fact, if someone does complete suicide. They really believe that if you ask the question, there's an opportunity for litigation and being held responsible. So those items are seldom included in many of the items, and that was certainly the case for the global distress, the LSQ, for this insurance company. We're going to talk about the one-parameter item measure, and when we look at the item curves and so forth, and we're going to focus on the global distress measure, we are expecting that the items will have curves that will be additive. In other words, those curves will not cross. When the curves start to cross, they're saying that the items are difficult at some levels for some people, and then they switch at other levels. And those items are really hard to determine. In other words, a person who is mildly depressed will answer one way, and then a person who is severely depressed will answer in another way. And if in fact the measure is measuring depression and it's unidimensional enough, it's very difficult to interpret those items. So what we're looking for in these graphics are sloping curves that are additive, that do not cross. So we see that the items suicidal, no interest, feeling stressed, feeling blue, and so forth really fit the model. But then we're seeing that as we move to the graphic on the right, we're seeing that some of the curves are crossing. The curves that are crossing are, in fact, the trouble with alcohol, criticizing my drinking, and so forth. The alcohol items are really crossing. So that's an indication that we might have some difficulty in terms of unidimensionality, that abuse and dependence may in fact be different than psychological and emotional distress. So this is a violation, one indication of a violation of the unidimensionality. And what the question is, as I said before, does it divert from unidimensionality enough? So here's an example when we talk about questions. We're talking about which item is more difficult. We have the probability of scoring higher on the red item is at 0.6. We're just putting this. So the person with psychological distress between mild and moderate, say that it's low moderate, is 0.6. But on this other item, this green item, all of a sudden a person who has more severe, this person is between moderate and mild, this person is scoring 0.9. So we have, at what point, which item is more difficult? We're interpreting the red item in a different way for the mild, moderate part of the sample. We're interpreting the green item, this is a hypothetical item, in a very different way for the moderate severe item. So when we're talking about item difficulty, we're talking about a shifting of the items in terms of their difficulty. They're difficult for moderate severe, but then they're less difficult for mild and moderate. And it becomes very difficult to interpret which item is more difficult. That's called Lord's paradox. So are two parameters better, and so forth? In measurement development, we always want to go with a more parsimonious model. Good data fit the measurement model. The objective is to minimize the measurement variance, not to explain it. So if I'm really conducting psychotherapy research, I really want a good, precise measure, not one that I can explain the variance about, and so forth. So we're going to examine dimensionality. So we have examined dimensionality. The question is, unidimensionality is necessary if we want to interpret the score as being characteristic of a construct. If we're calculating a summative score or a mean score across items, we want to make sure that that one score is psychological distress, that it's depression or anxiety, and so forth. Item discrimination can be examined as a method of identifying problematic levels, the potential for multidimensionality. So measures that may be seemingly unidimensional may in fact be multidimensional. Any time that we are giving people a measure to fill out, we are automatically measuring two constructs. We may be measuring depression, and we feel that we have a very, very strong unidimensional measure of depression. However, we're also measuring literacy skills because we're assuming that the person is interpreting the measure, has the ability to read that measure, and so forth. If that is true, then the unidimensionality assumption holds true. If in fact literacy skills really can vary and the person is bringing a misinterpretation to that measure, we're measuring two constructs. So literacy may be a hidden dimension, and the literacy skills may be attributable and a characteristic of multidimensionality when in fact the measure is really unidimensional, if in fact the reading level was appropriate for all of our respondents. But we have to remember that we're dealing with people who have impairment and so forth, so they're experiencing distress. Multidimensionality means that more than one distinct attribute is being measured. In the case of the measure that I showed you, the global distress, my assumption is that we have some psychological distress and that substance abuse is in fact different. On this particular measure, we have a mild person, we have some moderate people, and we have some severe people. So let's take a look. Is it one construct or two, this 30-item global distress? So it's scored from 0 to 4. The scores range from 0 to 120. High scores, greater impairment. 27 aspects address psychological and emotional distress, interpersonal problems, and 3 items really address serious substance abuse. Now the 27 items that are characteristic of psychological and emotional distress really range from mild distress to more severe distress, while the alcohol and drug items are really at the severe end of the scale. So we have a person who has no substance abuse, no issues, has a score of 0. We have a person who has a max score on the substance abuse, all 3 items, and this person gets a score of 12 on those 3 items. But so we have people at both ends. These are just the substance abuse items. So we have all of the 27 items. A person gets a score of 12 in terms of depression. A person would be mild in terms of depression. A person who is mild on depression gets a score of 14, and so forth. But that score of 14, if you look in the top ruler, and the person says that, you know, I'm really happy. My drug and alcohol addiction and so forth make me happy and so forth. I'm answering truthfully. The people are criticizing it, but as long as I'm using, I'm not sad. I'm not just depressed. I'm not anxious, and so forth. So the person gets a score of 12, and that person, if you were looking at the total score on this measure, would be characteristic of not having a problem. But if in fact you looked at the content of those items that were representative of that score of 12, that person would be considered to have a serious problem, and from the perspective of a psychotherapist. So the implications of dimensionality: you have a person with a mild problem of 12, a person with a score of 26, and so forth. It depends on where what's the content that is reflective of that 12 items. But in classical test theory, we're making an assumption that all of the items really contribute equivalently, and they really don't. So you would say that would sufficient treatment be authorized for the individual with mild or moderate, the score of 12? If it was 12 across the 27 items, you might say that the insurance company might say that, well, you know, that person has very mild depression and we're not going to pay for it. But if in fact the insurance company knew that that score of 12 really was indicative of very serious addictive problems with regard to drugs and alcohol, the treatment decision would be markedly different. When we talk about the Roche and the 2-parameter model, one of the things that you do is when you see that the items cross, that the lines cross, you want to run a Roche and a 2-parameter model. And we see that we have 4 items, suicidal thoughts, and the 3 drug items and so forth. And we're looking at the 2-parameter location and the slope to see if they are vastly different from the Roche parameter estimates. For suicide, we see that the location is on the Roche model is 2.4. For the 2-parameter model, it is 2.6. It is a distinction without a marked difference. However, we see that the parameter locations for the alcohol items are in fact significant. So the 2-parameter model would fit the data better than the Roche model. But another alternative, rather than just explaining the data, would be to say that this is a multidimensional measure, and in fact, we should probably take these 3 items, score them separately, and the 30-item scale should yield 2 subscale scores, one for the 27 psychological and emotional distress items, and one for the 3 alcohol and drug items. So that is one approach. We're going to check a different approach and really focuses on the use of a bifactor model. If in fact we go back to the global distress scale, the global distress scale, the 30-item scale, is purported to measure 4 sub-factors. But the sub-factors are, the subscale scores are for the most part pretty highly correlated. And if you have subscale scores that are so highly correlated, you can introduce multicollinarity if in fact they're treated separately. The truth is, on that 30-item measure, that the factor structure is pretty weak in terms of the 4-factor solution. In fact, the authors, Mike Lambert et al., really recommended to the insurance company that that 30-item scale be used as a single total scale score, just summative across the 30 items. However, the distinction between the 3 alcohol items and the remaining 27 items is distinct enough to warrant the use of a sub-factor score for the 27 items and a separate score for the 3 items. Another way to go about this is bifactor models. Bifactor models are becoming much more prevalent. They are part of the gold standard of measurement for the NIH in the United States, National Institutes of Health, and the PROMIS endeavor, which is the Patient-Reported Outcome Measurement Information System. We're going to use the Eureka for that. The Eureka is composed of 4 subscales: pre-contemplation, contemplation, action, and maintenance. And essentially, the 1-factor, this is on the left-hand side, you see the 1-factor readiness to change, but the 4 factors are used, and this is a measure that is consistently used in alcohol and drug abuse and dependence studies, and was certainly used in the cocaine collaborative study. And you see the 4 the items are equally distributed across the 4 factors. This is the 1-factor solution and the 4-factor solution. The 1-factor, the variance is explained 27%. The first factor explains an additional 25%, 6.9%, 4.7%, and 2.81%. Sorry for the fact that the variance explained isn't pushed to the right columns. This is one of the big problems about doing your slides on a Mac platform and showing them on a Windows platform. You can clearly see that we have some items that are loading on multiple items, and you can see that in fact not all of the items are loading where they're supposed to be loading. This is a Verimax rotation and so forth. This is a traditional, this would be a confirmatory factor analysis. And we see that there's a lot of items, especially the items are blocked in terms, the top items are pre-contemplation, contemplation, action, and maintenance. And we see a lot of overlap in terms of items in terms of the action and the maintenance factor. And some overlap between contemplation and maintenance. So this is very problematic. For the bifactor model, I use the Schmid-Lehman model. You can get the, if you're using SAS or SPSS, it's available. The code is available on the website. And it's a confirmatory-based IRT model. It uses IRT scores. The items are free to load on the general factor. One of the premises of a bifactor model is that the items can load on both the general factor and a secondary factor. But the assumption is that they will only load on a distinct secondary factor. And comparisons can be made between the loadings on the unidimensional general factor and the loadings on that second factor. And this is the way it looked. And what's interesting about the Eureka is that while it has 32 items, there are 4 items that are deleted and not scored. So I've always been wanting to ask DiClemente why include an item that you don't score. It increases the respondent burden, but I haven't done that, and there's no explanation for that. Essentially, this is the bifactor solution, and we have a general factor, and as I said, these the syntax for that only allows the item to load on the factor to which the secondary factor to which it's assigned to. And we see the blockage of these items. The general factor explains 82% of the variance. The first factor explains 4% of the variance. We get another bump of 4% with factor 2, which is assumed to be contemplation. Factor 3, action, accounts for 10%, and the maintenance accounts for a very dismal 0.3% of the variance. And then what we're doing is we're really comparing the loading. So if we look at the bottom block, we see that the first item, item 6, which loads on the maintenance factor. On the particular factor, it has a loading. First of all, it doesn't load on factor 4. The loadings are really on factor 3. The secondary factor loading is a 0.302. The loading on the general factor is 0.340. Not very distinct. And if you go and you check out all of these, and if you write to me my email, I will send you these slides and you can look at this more thoroughly. So the bifactor results for this particular analysis really indicate and bring into question, are there really four distinct factors that are informative in terms of readiness to change? Readiness to change is a construct thought to be very important, especially in addictive disorder treatment. So we're going to look at the standard item difficulty. So here's the pre-contemplation. So we would assume that pre-contemplation, when we're working with people with addictive and abuse and dependence disorders, that pre-contemplation, not agreeing that there's a problem, that's at the low end in terms of stages of change. At the higher end would be the contemplation. So we're saying that pre-contemplation and contemplation should really be distinct. But when we look at the responses that were generated from the sample of 1,700 people in the Cocaine Collaborative, we see that there's a complete overlap of these responses. So the response profiles of these individuals do not clearly differentiate between people who are in the pre-contemplation. In other words, I don't have a problem. Somebody else thinks I have a problem. That's the only reason I'm in treatment. From the contemplation people who are saying, I might have a problem. Action overlaps both pre-contemplation and contemplation. And we see that we get the biggest distinction in terms of maintenance. These are the individuals, the action people are saying that I have a problem, I'm doing something about it. The maintenance people are saying, I have a problem, I know what works, I'm actively working to ensure that the improvement that I've made in terms of managing my sobriety or reducing my use is consistent, and I'm maintaining the good outcomes that I've experienced. So we clearly see that this is a very problematic measure. Pre-contemplation and contemplation completely overlaps. This is indicative and consistent with the Schmid-Lehman bifactor analysis and so forth. Some conclusions for this, the analyses, is that the use of the total score is, it really represents a unidimensional scale score in terms of readiness to change, that there's no distinction. A higher score may be indicative of more willingness to change than others and so forth. This is a measure that does not bring precision to the measurement model. The data do not fit the model, and this is a measure that I would not recommend using. Only the maintenance subscale items contribute substantively to the variance over and above the general factor. So if you were using this measure, I might single out the maintenance items, use them separately, but go back in and look at that, the Eureka in terms of the remaining items in that particular measure, probably cull them out and look at a measure that went from, problem recognition, no recognition, to some recognition, to willingness to admit that they have a problem. So questioning additivity, we're moving further further along. One of the big things that we have is that we create a response option scale. The reason that we create a response option scale is because we're making an assumption that we are, in fact, able to cull people out into these categories. People that strongly disagree, neither agree nor disagree, agree, strongly agree, and so forth. And if we can't, if we experience some individuals not consistently not using a response option, then they offer no information whatsoever. This is the global distress. These are two items. This is satisfied with relationships and being happy. And we clearly see that we have a distribution of people that we can allocate along the 5 different response options. What we want to see is these are response probability curves, and we want to see some portion of the response probability curve really surfacing. So these items are working well with a 5-point scale. We see having trouble with alcohol. We see that we see very little individuals in the disagree, and we see very little in the agree. What we're seeing is that we see that this is really operating as a 3-point scale. There are people who sort of agree that they have a problem, people who, on this side, people who disagree that they have a problem, and some people in the middle. We see using drugs and alcohol to get going, and we see that all of the 3 response scales, response options in the middle are completely subsumed. This item is really functioning as a dichotomous item. The use of the 5-point response option is introducing noise into the measurement model. So again, if in fact we were culling out the 27 items on this global distress scale and using the 3 alcohol and drug items separately, I would actually score them on a different response option scale. And we see that we have the Logit distribution over here. We have a 7.15. We capture a lot of people here. We capture very, very, very few people in this area. And and remember that as we move from the left to the right, we're dealing with people who have higher levels of the problem.
And if I may interrupt, I think we're almost out of time.
Okay. We'll go very quickly here. And let me just say that people criticize this is just another way of looking at it. One of the things I want to go towards is, let's see, questioning the additivity. So if we talk about the eureka and so forth, and we're adding people in terms of scales, there's scale overlap, it violates additivity. The last thing I'll introduce is error. Before we said one of the assumptions of either classical test theory or item response theory measurement is that the error is uncorrelated. We clearly see that error is attributed, it's not uncorrelated. Higher levels of error are systematically attributed to scores that are at the tail ends of our distribution. And this is just another way of showing it. This particular line talks about the test information. We get most of our information here on this test. We get very little information in terms of the tail ends because that's where we have the most error. We see that we have uncorrelated error for most of the test, but items that are at the tail ends of our response distribution have correlated error. We'll stop here and we'll have some questions.
Thank you, Anne, for your very interesting talk. I personally found it very interesting as I both use the OQ45 and the Eureka in some of my research, so it was very interesting to me. Let me say, Kim, that it was the LSQ, which is a 30-item version that was developed for an insurance company, and I dare say the insurance company had a lot to say about what items were included and not included. Mm-hmm. Yeah, but I could recognize the OQ45 items in there. What I found really interesting was that actually from the work that I've done, not using IRT but using classical test theory, for some reason I get a similar feel of the questionnaires and the items performing a bit difficulty in that questionnaire compared to what you've just shown us. So I found that very interesting because it seems like it's a different way of looking at it, but it still gives you, at least in some way, this similar conclusions to the performance of those items. Do you agree, or do you disagree with that?
I agree. You would arrive at the same conclusions whether you're using classical test theory or IRT. All of the information would be readily available in terms of any of the IRT analyses, whether you're using the Roche model, which is win steps or conquest, whether you're using bilog, multilog, parse scale, which would be for multi-parameter models. So all of this information would be yielded as the result of one analysis. With classical test theory, you would have to do multiple analyses in terms of determining deviation from unidimensionality. You would have to actually run separate analyses in terms of the adequacy and the precision of the response scale options as well.
Yeah. So I also have another question, and that is, if we use IRT, could we still use the total scores as an indication of some sort of general distress level, or how do we calculate them? Is it calculated in a different manner than that we're normally used to?
In Roche is the one-parameter model, so Roche produces measure scores, and the correlation between the measure scores and raw scores are very, very close. So one could say you could have slightly more precision using the measure scores which are produced, but you could also use the raw scores. And what the Roche analysis or the one-parameter model would say in the case of the global distress, the LSQ, would be you get much more precision by using a total scale score of 27 items and a total scale score of 3 items, and really talking about those differently. So that would be much more precise than summing across all 30 items.
Okay. Well, thank you. It's very interesting. Let me just see if there's questions from the public. Usually they're a bit shy in starting up. So does anyone have any questions? If you do, please type them in the question window or raise your hands. Just going to give people a little bit of time to do so. And I'm already going to say, before giving them a little bit of time, that we are very grateful that you did this, and we have recorded this. I'm not sure, did Sam discuss this with you? That we record the webinar and post it as a video in the secure surroundings of the SPR website. And so for anyone in the audience, but also I think particularly for those not in the audience, people can watch that on the SPR website.
Right. I just put up one last slide, Kim, and this actually shows, this is the insurance study, and using the raw scale scores where they looked at all 30 items, they determined that about 20% of the patients deteriorated. Using the Roche multidimensional items, in other words, the 27 versus the 3, only 8% of the patients deteriorated. So that's a marked difference.
Wow.
Yeah.
That is a big difference. Okay, we do have a question from the audience from Andrew. Andrew, I'm going to open your microphone. Go ahead.
Can you hear me?
Yes.
Oh, okay. My question regards 3-parameter models. I apologize, I missed I put this webinar in my schedule incorrectly, so I've just showed up. I'm wondering if you have thoughts on the 3-parameter model and what the utility of adding that pseudo-guessing parameter is in using psychological distress measures as opposed to like an academic achievement test, where conceptually I think it makes a lot more sense to me.
I think that Niels Waller has really demonstrated the utility of the three-parameter model in personality testing. And with the three-parameter model, you can actually at least identify the individuals who are trying to fake a certain personality style. I believe it's on my own personal bias is that when people come into treatment having experienced psychological or emotional distress, they're not trying to fake it, they're not trying to guess, and so forth, so that the one-parameter or two-parameter model is sufficient. One can always start with the one-parameter model. Even in the Roche model, the WIN steps, you can set the Roche analysis, and it will give you estimations for item difficulty and guessing. So you get that, and if in fact there's a deviation, we would assume that in the Roche model, the guessing and item discrimination would be 1. Any deviation from 1 would indicate that there was some guessing. The only role of guessing outside of personality testing or multiple choice, I think, would be in the case of a person who had marginal literacy skills. One of the things that we found out in a study that I actually did in Washington, D.C., is that people have great measurement completion skills independent of whether they can read or not. So if you hand them a measure and there are some little circles to fill in, the rule of thumb is to fill in 1 circle for every line, independent of whether you read the question or not. And we actually got some very aberrant response patterns that we could not explain with the three-parameter guessing. And we went back and interviewed individuals using cognitive interviews and found out that there was marginal literacy skills for the people who were participating in this methadone clinic.
Okay. Thank you. That's very helpful.
You're welcome.
I'm planning to go back and listen to the entire webinar now.
And any of you, please, I think the last slide is up on the screen.
Unmuted.
I will send you the slide deck that I use.
Muted.
Great. Thank you. Thank you very
You're
much.
welcome.
Thank you, Anne. I think that will, I would at least be interested in that. Are there also some articles available about things that you talked about, the 2 studies with the LSQ and the Eureka?
Yes, I will actually send you a list. And in fact, the Eureka is very interesting. It was presented to NIDA and NIAAA, and in fact, they talked about the fact, and in the literature, the factor structure of that measure has been very difficult to confirm. Yet, the myth of those 4 distinct factors has prevailed even in the presence of empirical data. So I'm a reading list.
Great, thank you. Okay, so I want to thank you very much, Anne, and I just want to announce that our next webinar will be by Irene Elking and will be in November. So thank you all for listening and for attending, and we'll hope to see you all at the next webinar.
Thank you.